Hello, my name is Manvir Saini.
And my name is Harmanpreet Singh Chima, and we will be presenting our project decision support system for medical diagnosis using data mining. So this project includes a wireless sensor network design for real-time monitoring and detection of cardiovascular diseases. This system, this system incorporates wireless network sensor technologies with other wireless technologies. All of these together will provide a cardiac patient ECG signal analysis, remote monitoring, warning distribution to a doctor, relative, and hospital, and an expanded transmission services of the patient ECG signals and prior to the record his doctor in a remote place. The system can be used to deliver improved healthcare facilities to developing countries, rural regions that face a shortage of effective specialized physicians. Thus, by implementing this suggested scheme, the cardiovascular diseases that cause patient death can be greatly decreased in both rural and urban regions. So this project is basically using, just to give you overview, is using data collected by the devices that we are using to predict whether the person is on the verge of any heart attack, using algorithms like Navi bias and decision tree algorithm to predict whether a person is close to getting a heart attack. So I will hand it over to Manu for the next part.
So the hardware that we use um, were a temperature sensor, pulse sensor, Arduino, and EMOSD1, which is a Wi-Fi that that comes with Arduino to connect um, our code or to connect our pulse sensor and temperature sensor to our website. So the first algorithm we used was the Navy Spice algorithm. It is a probability theorem, often called Bayes' law, after Thomas Bayes, relates the conditional and marginal probabilities of two random events. It is often used to compute um, posterior probability given observation. So, for like example, for a certain symptoms, a patient may be observed. Bayes' theorem can be used to calculate the likelihood of a suggested diagnostic being right given that observation. The next that we used was the Bayesian theory, which is which is given training data X posterior probability of a hypothesis following the Bayes theorem. Navi's Bayes algorithm is based on the Bayesian theorem as given, and the formula that we used was P parentheses X slash X, which is equal to P X slash H parentheses P H slash PX. Uh, so the diagram that we drew was the heart rate monitor, body temperature, and the sensor that the patient has it on himself that goes to our device. Then the device goes to the server, and the server goes to the database, and you can see the interface, the user interface, where he uses his vitals, and by getting the information that's stored in the database, we could predict whether the person is on the verge of a heart disease. On our software, the software is for the device to send data and recalibrate it and display it on the website so the patient could view it, and the patient's doctor can view it. For the on the website we have managed patient status and contact information. The program we used were HTML, MySQL, and SQL for database to storing our data that we collect from the persons, and we use CSS. Um, that will be it, and thank you.
Thank you very much.
Hello, this is Manvir Saini.
And this is Harmanpreet Singh Chima. We are starting our project with introducing our hardware. So we're gonna mention some of the components that we use in our hardware. So this right here is our pulse sensor, and this right here is our temperature sensor. This is our Arduino, and this is our
EMOSD1 or
Yeah.
Wi-Fi.
So we start by plugging in our hardware into our laptops to give it a power source. So as you can see, as soon as we connect our hardware to our laptop, a green light pops up in the pulse sensor that shows us that there is a source of power being supplied to our hardware.
Then we connect our hardware to our Wi-Fi, and the Wi-Fi source that we use is our mobile hotspot. So after we turn on the mobile hotspot, our Arduino is gonna connect to our hotspot. And when it does connect to the hotspot, you can see our Arduino connection. We get the it's connected to our hotspot. So then we go to our website that we created. First we log in. And you can clearly see like we have manage patient status, step range, data analytic result, and log out. So after we go to manage patients, you can see like we have like how many users right now we have. These are our test subjects, and right now we only have 7 test subjects. If we want, we could add more, like give them a name. So we could give Parwa, and his age could be like whatever, 45. He's a male. And when we fill out the vitals,
So these are basically all the different categories that a doctor might need to put into the system for it to have a better understanding about the patient, for data inputs and all that kind of stuff.
so after the doctor does everything and give them a clear record on what the vial should look like, and we save it, you can see the new user has been added. And after, we're gonna show you like a little demo where Harmanpreet's gonna hold the pulse sensor and the temperature sensor in his hand, and we're gonna get a reading.
So how much time does it take? It was
It-
40.
It takes 30 seconds.
Yeah, 30 seconds to give us a reading. So I have my temperature sensor right here and the pulse sensor right here to give us a pulse reading and temperature reading.
And you clearly see after it's been updated, you could see we got the new reading, which was 12 and 27.
The reason it might have given us 12 is because I tried to show you my pulse sensor like this, so it may have been an error because I removed a little bit of my contact from the sensor, but usually it gives the correct reading.
And for the body temperature, it shows 27, but it's reading as Celsius.
Not Fahrenheit. So we can convert it into Celsius. So we're gonna tweak that a little bit with our code, and otherwise, like in Celsius, also it's completely valid.
And this is our project right now. And you can see when we log out, it logs us out. And thank you very much.